Hello, and welcome to the 7th Mars Chronicles podcast and the first Mars Chronicles podcast of the year 2026. We took a little break from the podcast and enjoyed the holidays a bit. We hope you did too. With me back on screen as usual, Alessandro, thanks for joining us again today.
Yes, of course. Hi, hello, glad to be here.
Yes, and today it's a bit different again. Today, we're welcoming our first guest on the Mars Chronicles podcast, Thomas Herzig, whom I've previously had the pleasure of hosting. That was several years ago now. We'll bring him in right away and say hello. Hi, Thomas. Thanks for taking the time.
Hello, nice to see you all. I'm glad we could meet here. It was in 2022 that was live back then with on YouTube, what do you call that? Live stream.
Live stream, yeah.
Exactly, yeah.
Wow, it's been 3 or 4 years already. Time flew by.
Time flies, time just slips away, yeah.
Crazy. Oh, for everyone who doesn't know Thomas yet, who may have only discovered Mars Chronicles in the last 3 years, Thomas is an architect from Vienna and also specializes in space architecture. He has carried out and planned several projects for European Space Agency and has been funded by European Space Agency. And I also had the honor of writing the foreword to his book for European Space Agency. And today, Thomas has completed a project for European Space Agency, or at least finished one phase, and now we're here together to talk about it. Thomas, would you maybe like to briefly explain, using the PDF you sent me earlier, what you do and what you specialize in?
Okay, basically, I am an architect based in Vienna, and for almost 20 years now, I have specialized in pneumatic membrane structures, meaning inflatable buildings, inflatable objects, and so on. And in the year 2018, I got in touch with an astrophysicist from Hungary who had the idea to develop a Mars habitat, specifically an inflatable structure. We'll come back to why inflatable structures are especially practical in space. And then he visited me in Vienna, and I immediately saw that he didn't have any money at all. That's basically just a pipe dream, but I was so fascinated by the idea that I kept working on it. And then we actually developed this Mars habitat. And based on that, we applied to the European Space Agency for funding through the Open Space Innovation Platform program. And after a long selection process, we were granted this funding. Then we did a design study for a lunar habitat for the European Space Agency that was also back then, as we already talked about when you interviewed me. And since then, a lot has happened again. Because due to the design study for the lunar habitat, which consists of inflatable modules, I came to the realization that this construction method could also make a lot of sense here on Earth. Let's move on to the next frame. Yeah, these are just a few normal inflatable objects that I usually make. You can see an octopus in the top right, which was on display in Vienna at Karlsplatz in August. Next picture. Yes, this is now the moon-based design. So one of the poles, this would work for either the North or South Pole, because there, the sunlight always grazes over it continuously. And there are exposed crater rims or mountain peaks where sunlight is actually available almost all year round. It comes in horizontally, and in this case, well, maybe let's go to the next image. Exactly, let's stay here for a moment. So there's a mirror at the top that rotates once a month and follows the sunlight, and then the sunlight is reflected down onto a second cone-shaped mirror, and that reflects the light into a torus-shaped greenhouse where food and oxygen are produced independently. And the whole thing is a modular system with inflatable corridor elements, sleeping quarters, etc. The advantage is that the payload is very, very low, but you can still prefabricate it on Earth. Because the problem with 3D printing is, first of all, you have to rely on some robots to print it reliably. That takes a very long time and also requires relatively, for Earth, it's not much energy, but for the moon it is, since there's no electricity available there. And even then, I still don't have any guarantee that the 3D printed wall is really airtight. So it's best to always line it with a membrane as well. And in our case, we have all of that is prefabricated on Earth and covered with regolith for protection against cosmic radiation, meteorite impacts, and of course, extreme temperatures. And with that, the membrane can also be made much lighter and simpler, for example, compared to the inflatable module on the International Space Station, which also has to withstand space debris impacts and so on. And yes, and statically, it's also the case that the atmospheric pressure we have here on Earth and that we need to breathe, that's 10 tons per square meter compared to a vacuum. And because of that, I don't need to worry about the strength. And if the air should run out, then the first problem is more that the people inside would suffocate rather than it collapsing or something like that. That's the idea behind it. Let's move on to the next one. Slide. That was the previous one.
Oh, I see. So?
You can see everything covered with regolith from the same perspective. From outside, only the towers with reflective foils are visible. Now let's move on. Yeah, that's...
Apparently inside here. There.
Yes, there's a sectional drawing of the lunar habitat with just the Miro tower. You can already see how it's reflected down from above and then further reflected into the greenhouse. It's designed so that you can actually survive there autonomously without any supplies from Earth. That was always my approach. With the possibility as simply as possible. Not high-tech, but low-tech, with things that nature already provides and that have been working in nature for millions of years. The mirror film has the advantage that I can already filter out the ultraviolet radiation with it, because, for example, if the mirror is coated not with aluminum but with silver, then a large part of the ultraviolet radiation is simply absorbed, and then we have a similar amount of ultraviolet as we do down on the Earth's surface.
And how much does this construction that we're seeing weigh now, aside from this regolithic shielding? Yes, just the construction itself.
The torus-shaped greenhouse has a diameter, wait, what was it? 22 to 23 meters. And the smaller diameter, so basically the thickness of the greenhouse, is 5 meters 20.
Okay.
Inside, I have about 250 square meters, which means I can feed up to 3 people on the moon, so provide them with food and oxygen. And then you also have to add the areas from the corridors and the sleeping quarters and so on, and the tower on top, the mirror tower and so on. And altogether, it would be a maximum of 4 tons.
That's when you think about what Starship will be capable of. Not just Starship, even Blue Moon. And the smaller countries could transport something like that.
You could transport that in the 150 tons of cargo from Starship.
Yeah, that would just be a small corner somewhere. Yeah, that's insane.
How is it here now? I find it fascinating. I saw something earlier, but can't see it clearly now. I think it said magnetic ring rail.
Yeah, you know...
Are you using some kind of levitation technique here, so to speak, so you can rotate the tower?
Right, the tower must follow the sun. Now the question is...
Exactly.
The best mechanism to rotate it, some gears or rails. Dust gets in everywhere, so the best is a magnetic ring because it basically floats and isn't sensitive to dust.
Okay, so that's kind of a regolith protection thing in that sense, because a classic ball bearing would break immediately, I'd say, right?
Mm-hmm.
The tower, again, since there's only 1/6 gravity, it only has, I don't know, altogether, as far as I know, it's not 300 kilograms or anything like that.
Insane.
And spread over the circumference, that's, I think, let's say 13 meters in circumference. So the ring has 40, a good 40 running meters, so the weight is distributed. That means the magnet doesn't have to carry very much.
And this mirror itself, maybe also for the viewers, if I interpreted it correctly earlier from the slides. I also watched your video on YouTube, and there they always talk about a mirror membrane. So it's not a heavy glass mirror as we might think, right? It's more like a stretched film, isn't it?
Yes, it's a Kapton film, so it's similar to the material they use for satellites. For packing, it's really just a thin film, and then it's stretched and curved a bit using an electromagnetic field.
That really looks super delicate, right? I mean, it looks very, very delicate. How do you make sure it stays stable?
Well, those are carbon fiber tubes, and the shape is what's called a hyperboloid. So you have to imagine, let's say you have a cylinder, and you have a bunch of vertical carbon fiber tubes. And at the bottom, you have a ring. And at the top, you basically have another ring. And these tubes run between them. And now you twist the top ring a little bit. That makes the carbon fiber rods tilt, and it kind of creates a waist, as you can see. It's a bit tapered toward the middle, and then I basically have a second row running in the opposite direction, and at the crossing points they're connected, and that gives me a stable framework. The advantage is that I can simply transport a bundle of straight rods like this in the spaceship.
Super exciting. That's really cool.
So how tall is it?
Excuse me, what?
How tall is it?
In that case, the center of the mirror is about 12 meters above the lower ring.
I think we talked about it for the first time, and I was really fascinated. Even though the whole habitat, as I'll call it, is covered with meters thick regolith, inside this structure, this membrane structure, is basically enough to hold everything together. Outside is a vacuum, while inside there's about 1 bar, maybe slightly less, or exactly 1 bar.
In my case, I said, let's reduce it to half a bar. That's about the same as on the summit of Mont Blanc or Grossglockner. And we increase the oxygen content a bit so that the structure isn't put under too much stress. The regolith's weight is irrelevant because most stress comes from internal pressure.
And I remember there was something that occupied my mind back then as well. The dust on the moon, it's sharp and jagged. What keeps this dust from just wearing down this membrane over time through micro movements and small grinding motions and simply breaking it down?
Then we add a foam layer, a protective layer on top where the foam can still be compressed a bit. And also the regolith that comes into direct contact there. It is then rotated again in something like a concrete mixer in a cylinder. And that causes the sand grains to be ground down, just like desert sand or at the sea. That's why it's no longer sharp-edged. The sand grains are always moving and rubbing together, making them round. That's not the case on the moon, which is why it's so sharp-edged there. But you can artificially create that later. Then we have the protective layer over it, and otherwise nothing moves anymore once it's...
Yes, and can you give an overview of it? This project was for European Space Agency as well, right?
Exactly, and that was completed in 2022, and then the idea came up. Well, but if this works now on the moon, that I can build something modular and easy to transport with so few resources, and in that case, I only have the sun as an energy source for heating and so on, then it should be a lot easier to do on Earth. And it also makes sense. For us, it's not a necessity for the mission to work at all because we have resources and energy, but it's still sensible to save them on Earth as well. And so I actually spent some time working on the concept theoretically, and there is one. So European Space Agency is a strictly structured multinational organization, which means they have specific funding channels and the director can't just decide, now let's just give Thomas Herzig $1 million. Yeah, so...
I can confirm that.
They can't award contracts without a tender. And there's European Space Agency that's called European Space Agency Business Incubation.
Center.
Business incubation stands for business incubation. So I submitted a funding application there. So this exists in Austria and in a few other European countries, although in Austria it's only available for Lower Austria, Salzburg, and Styria.
Oh, I see. That's interesting. So it's different there?
Because those federal states also participate in the funding.
Good to know.
Those who don't, or those who say the Viennese already have enough, and I'm Viennese myself, I even founded a new company in Lower Austria for that purpose.
But of course, it makes sense.
And I applied for a grant there. And that also takes about half a year until with the selection process. And then I was accepted in the summer of 2024. And this grant made it possible for me to build a prototype on my property in Lower Austria.
Super exciting. I always find concepts like this interesting. I once saw one from Canada, but can't recall the name. It's always kind of about the whole need for light. So to stay mentally healthy or to grow plants and things like that, you also need real light. And I always see a bit of a connection here, actually. Of course, we're talking about space travel and about what would happen on the moon or on other planets. But this technology, this whole mirror principle, is also brilliant for bringing daylight deep underground, or in this case, to the lunar surface. Would you say, or do you also see an application for this on Earth specifically? So I'm thinking of things like lighting up subway stations or subway platforms with real sunlight instead of using regular electricity. Would something like that also be possible?
Yes, of course, you have to compare that because I don't always have a free space above where I can get sunlight. I mean, often there are already skylights and such in subway passages and the like. But the problem is that the area above is usually occupied by something else, and I can't just put a mirror tower or something like that there. Or maybe I could, but electricity is just much cheaper than the construction effort. In my case, it's a bit different because the amount of light I need for people so that they can see normally is much, much less than what I need for photosynthesis. Just as an example, here on Earth, on a bright sunny midday, about 1,000 watts per square meter of sunlight reach the ground. That translates to about 100,000 lux, which is the illuminance, in a living room in an apartment. When normal daylight comes in through the window, 500 lux is already enough for you to perceive it as normal daylight. So 1,000 lux is already really nicely lit. The human eye adapts so well that you don't even notice that it's only 1/100th of the original amount of light that's there. I mean, plants are also, of course, so ideally plants need 15,000 lux for growth. Anything beyond that, they can't really handle, at least the normal crops that we have. Of course, a cactus or corn can handle a bit more, but nature has set it up so that plants can also get by with less. Because there are a lot of days when it's foggy, when it's cloudy, when much less sunlight gets through, and the plants have to survive that and be able to grow normally.
Good point. Yeah.
Really exciting.
Sure, there are enough concepts for greenhouses and in space stations and habitats. They always want to use LED lights and stay underground and so on. But then I can only harvest lettuce. But what does it look like with aeroponics when it comes to composting organic waste? I just have a natural system where everything is composted and everything is constantly recycled. And I have everything. I have oxygen, I have food, but I also have ecological diversity. And above all, I have a habitat for the people there. Because by nature, we're used to being able to go outside and spend time in a forest or at least in a garden. So this greenhouse is much more, it's actually a living space and a place to stay.
Mm-hmm. Yes, what might be quite interesting also for the viewers and listeners at this point or at this place, what Thomas has just explained so nicely here, with the lux and our perception, well, in the end, our perception behaves a bit logarithmically, just in terms of how it works, but lux is still a linear unit of measurement. You really have to distinguish between those things here. Not that anyone here would somehow misunderstand this, because lux is already very human-centered in that regard. And of course, that's also critical here, as Thomas described or describes in his project or projects. As humans, we actually want lux. That's basically a lot of green content, which would be great, but plants actually hate that as a standard. Maybe this here is an ad.
For the audience, what does logarithmic mean?
Logarithmic? I'll let Thomas handle that. I don't want to do all the talking.
Yes, logarithmic. So with decibels, and that's how it's done. For example, if I have instead of 10 decibels or 10 lux, 20 lux, that doesn't mean the physical energy intensity is doubled, but rather it's, I don't know exactly how much, but it increases. It's basically a logarithmic curve, which means that double the numerical value actually represents 10 times the physical strength.
Okay, jumps.
So linear, very classic. You have a spectrum, you don't have a curve, you have a straight line, 1, 2, 3, whatever. If you have a logarithmic scale similar to exponential, you get big jumps like 1, 10, 100, 1000, and so on. So in short, to perceive a brightness as twice as strong, you have to increase the amount of light tenfold. So that's linear. You have one candle, you add another one, then it's twice as bright. Logarithmic, if you have 100 candles and add one, you won't notice a difference. So you would have to add almost 900 or something like that, or somewhere in that range to get to 1000 in order to notice another jump, so to speak.
Orders of magnitude.
Yes, that's really just a matter of scale.
Okay, very interesting. Now I know that too.
That's why dimming light is hard. We occasionally have this problem with our cameras, Cinnoir.
That's the...
Yes.
Okay. And Thomas, you went through a certain evolution, didn't you? That's not really the reason why we actually gathered here today. That's more or less just the starting point. And other things developed from this project. What happened then?
Let's move on, exactly. Let's move on to the next slides, yes.
Why does it keep returning to the beginning?
Yeah, that was still the greenhouse in the moon habitat.
Exactly. And the nice thing about this design is that because at the lunar south pole, the sun basically shines by almost 24 hours a day, or actually all year round continuously. And you build this tower, you can more or less create your own daily rhythm. You can pretty much decide how many hours of daylight you have and how many hours of night there are.
We of course turn it away from the sun for at least 6 hours a day so that we can simulate a night cycle. The plants need that too, but of course I can generate significantly more hours of sunlight there than I normally have on Earth. So how is it I can capture about, let's say, 4 times as much sunlight there? So not too much of the optimal amount either, but just enough for those 15,000 lux or about 260 watts per square meter, something like that. That's the ideal amount, and I can provide that for 18 hours a day. There are just a few days in the year when it's unfavorable, when some other crater rim casts a shadow and so on. Or of course, these light towers, these mirror towers, they also briefly cast shadows on each other from time to time.
Yeah, I think we'll think about that.
This image really makes you reflect and philosophize. I thought that before.
Yeah, really cool.
That's really cool.
Well, I still have dozens of questions about this picture, but I'd like to get to the point.
Let's move on to the next one.
Which is why we
Yes. Then there was the Mars habitat design, which actually came before the moon habitat. But after the moon habitat, I also developed the Mars habitat a bit further. There you can see the central area. Those are the communal spaces. And on the left and right in the background, those are actually the regular living and greenhouse units. Of course, it looks quite different on Mars now because we're at the Martian equator and the lighting conditions are different there. On the moon, I always have sunlight coming in horizontally, circling around the horizon. And at the equator, the light basically comes straight down from above at 90 degrees with a seasonal deviation of 24 degrees. And now I have to direct the light inside. That's why they're parallel. Let's move on in the picture. Exactly, you can see these from above. They're also naturally covered with regolith. In between, I have photovoltaics underneath, and then you see it like little gable roofs. Those are mirror foils that are stretched, and they reflect the light that comes in from above sideways into the greenhouses.
That's brilliant.
Yeah, you can't see the greenhouse from the outside now, so that's also the case. The film is transparent, but it's reinforced on the outside with a diagonal rope net. It's like those, you know those sausages or some kind of ham that are in a net like that, because the film alone, unless I use Kevlar or something, these fabrics handle pressure well, but aren't transparent, while the transparent material has limited tear resistance. That's why I have to reinforce it again with a rope net like that.
And you have to ask again, what actually prevents the Martian dust from scratching or tearing through this seemingly thin film? Or what happens if an astronaut stumbles against it from the inside? And that?
The film is designed to be double layered. At least that's how we made it. That means if you bump into it in a stupid way, we also have this rhombus pattern that you pressed into the facade. It's everywhere. And each rhombus is its own sealed cushion. If I were to poke it from the side now, the second layer of film would still be there to hold the pressure. And then you can do that, and it's also like this. If you poke it now, if the inner film is damaged, the cushion loses pressure. That means the outer film keeps stretching outward, and the inner part of the cushion just hangs there loosely. You think, check, maybe inspect automatically with drones or robots and notice something's wrong with the cushion. If the outer cushion is damaged, the inner cushion would be pushed out. And with that, wherever something is perforated, you can then patch the hole.
Visual early warning system.
Yes.
These days, you just have to use AI.
You do, but by then it will happen automatically and no one will need to go around. Or you could put one in every pillow. You could, for a Mars habitat, you can afford to have a small sensor built in everywhere. And
The ratio here is also interesting. It really looks like we need much more space. I mean, really a lot more space for our plants than for ourselves somehow. What would you say? Would we end up being more like farmers on Mars
that with a small terrarium,
than astronauts?
since you can feed a lot of people now, like in some illustrations. No, so on the moon, I calculated that I would need about, people compare this with those advanced greenhouses. I also have to consider that I get more consistent sunlight now, but still on these 250 square meters, I can sustainably feed a maximum of 3 people. You also have to mention vertical farming with LED lights. That only works for salad things that are basically made almost entirely of water and don't really have any real nutritional value. So yes, vitamins too, but not carbohydrates. It's always about the mass and the carbohydrates. And for that, you need a lot of light and also growing space. And that on Mars, I need more than on the moon since there's less sunlight available. And nuclear reactors that generate electricity aren't an option because these nuclear reactors are still very heavy. A 10 kilowatt continuous electric power kilopower reactor weighs 1,500 kilograms. So, and you have to get that to Mars in the first place.
Yeah, that makes sense. It all looks like a rather classic greenhouse, like the kind, if you imagine a greenhouse in quotes, or want to imagine one on another planet. How is it with the radiation here then? Do these foils and the whole framework and structure also protect against the radiation?
Go to the next picture so we can understand better. Exactly.
Okay.
All of it, the fill comes from, well, it's up there, it's held back at the top. And where the mirror is full, you can't really see that well in the picture. There's also regolith piled up between the mirror foils. That blocks what's coming from the side. The roof sticks out a bit, so there's really only a minimal area left where radiation could get in, right? And if I'm not standing right at the front by the transparent wall of the greenhouse, but a little further inside, as you can see in the drawing, the woman lying inside, then I'm already completely out of this radiation field.
That's really exciting. And that one long thing, on Mars, it's basically, so there are about 250 square meters for 3 people, right?
On the moon, no. On Mars, I think we'll need about 400 square meters per person. Me, because I can't constantly add artificial fertilizer, I can only recycle what's from organic waste. I also need so maybe I can manage that 50% of the plant material is edible for humans. The rest must first be broken down by other animals or microbes. And that then turns back into carbon monoxide, too, which is then photosynthesized again by the plants. Yeah, so on Mars, even at the equator, there I have about as much sunlight as we do in Scandinavia, maybe a bit more because there aren't any clouds or not as many clouds. But in return, I have the dust storms. But overall, I have to, and of course I can use the mirror to focus a bit more light in. I can increase the amount of light. So that even in the case of a dust storm, plant growth is still possible. So with them, the dust storms aren't that critical. They reduce the sunlight to about 30% of what I would have with a clear sky, and that's not that little. So when it's cloudy on Earth, it gets reduced much more.
Interesting. Very exciting. So let's look at the next one.
So this is now, and here's the application on Earth. I have to say also, in case anyone is interested, so European Space Agency Business Incubation Center specifically supports upstream or downstream applications, meaning space technology that is then applied on Earth or vice versa. And that's where my project also fit in thematically. And yeah, so it's about this here. I always call it Numo Planet. That's why we need very little building material. We hardly need any resources because it's made only of thin membranes. And then we use the thermal and other capacities of the ground for which I would otherwise need thick walls. Because the advantage is that within the ground, the temperature stays relatively balanced throughout the whole year. And on top of that, I also get an insulating effect. And the goal with that is to say, okay, I don't need any energy for heating or cooling. I need minimal resources for building materials. Additionally, due to the high degree of prefabrication, it's a third cheaper than a conventional building. Yeah, I do too. I can, for example, choose a few optimal production sites worldwide, and it hardly has any transport weight or transport volume. And I can, let's say, with 20 square meters, such a room module only weighs about 100 kilograms, for example, and I can ship and use it anywhere. But let's move on to the next one. Yes, you can see a 3D cross-section here. On the left is the airlock with 2 doors, of course, and then I have an example of a room there. The yellow top is thermal insulation, since I mainly need to insulate upwards. Towards the ground, I can make it a bit more permeable so that there is a thermal exchange with the Earth. Then we see this, but of course it doesn't really look like that. This is symbolic, this blue and red wavy line. Those are air ducts that I use to draw in or release air for ventilation. And with that, in winter, the air is preheated by the Earth, and in summer, it is pre-cooled. Because then, well, it simply takes on the temperature of the ground.
And how deep does...
Can it handle very cold temperatures like in January? Can it also be paired with traditional underground heat storage similar to hydrogen systems?
I'll get to that. So I built a prototype. And that you could, of course, add some other things, but basically it's designed so that the balance from heating through the ground is enough. But let's go to the next picture, then we'll see it better. Yeah, this is a cross-section. Where is my prototype, actually? Because at the moment, I only have a single room as a prototype, and that's how it's built. That means the yellow all around is the thermal insulation. Then we have brown, which is the normal soil outside. And then between the inflatable room and the thermal insulation. That's actually where the thermal exchange happens now between the indoor air and the soil. That means the soil there is much warmer in winter because it retains the heat. And you can also see I intentionally didn't completely close the thermal insulation on the floor. And it's also thinner there because that's where more exchange is supposed to happen. In the summer, I mainly want as much of the heat as possible to be absorbed, and that in the wind. Some of the heat is lost, it dissipates into the ground, but not as much as upwards into the air. And that I also have this temperature curve. So of course, let's say I'm somewhere in December, and let's assume the air temperature is 0 degrees. But then just a few centimeters below the ground, it's already quite a bit warmer, namely +4 degrees. So I'm already free of frost there. And the deeper I go, the more it approaches the annual average value of +10 degrees. So from a depth of 3 meters, the temperature remains almost constant throughout the year above this average value. And let's move on to the next picture. Hold on, that's not it. Next one, then we'll go back. Wait, it was somewhere. These are the temperature curves. So this orange graph curve, the one that fluctuates the most, that's the air temperature over the year, the monthly averages, and the other curves. These are now the temperature fluctuations at different depths of the soil, and we can see that the deeper we go, the flatter it gets. But in addition, the highest point of the temperature and the lowest temperature are also shifted in time. July is the hottest month and January is the coldest. But underground, the maximum then shifts to September, October, and the minimum to March, April. And then I can take advantage of that because in April or so, The ground is already much colder, but I already have more solar gain and the air is warmer again and so on. And that's how I use the whole thing there. So now let's go back a little bit there.
I have a question about that, maybe briefly. Before we get into that, is there an additional layer of insulation like styrofoam used in between, or?
Well, something like that does exist. Yes, exactly. The yellow one there, that yellow-green one, that's styrofoam. So in my case, I put 20 centimeters of styrofoam all around. I should add, the prototype, it's just a single room with 15 square meters. And of course, that's not ideal because the smaller the building is, the worse the surface to volume ratio gets. If I build an entire single family house like this, then the surface area is smaller. That means I also need less thermal insulation, but in my case, I had to wrap it very well with insulation. And the cut, that's actually what I'll be doing next year. I just realized that during construction, at the moment, the roof is still sticking out of the ground like a small flat dome and the insulation is on the inside. And now I realized I could also spray polyurethane foam on the outside. And if I make a 15 centimeter thick layer of insulation from the foam and then put fiberglass mats all the way on the outside.
That makes sense, yes.
That's a really stable shell and it can even support up to 80 centimeters of soil. That means the whole thing is then covered. And the other advantage is if for some reason the air should escape, it doesn't collapse. I also said before, well, I'll let the roof stick out because if for some reason it collapses, they won't be buried underground. That was also a reason. Also, I preferred that. I don't want the high air pressure of the moon habitat since that's much more work technically. I basically have an overpressure inside, kind of like in a bouncy castle.
But that's planned for next year, right? So it hasn't been implemented yet?
It can't be done now. It's too cold to spray the foam. You need at least 10 degrees Celsius for it to harden properly.
Yeah, but honestly, when I look at these plans with the inflatable concrete earth house or something like that. So, sorry. I can easily imagine if I go to the German Building Authority, I'm not sure how it is in Austria, they'd probably call the police. I can really imagine that. Those are hurdles, even in the experimental field. What has your experience been like with that?
I haven't had any experience with the authorities yet because this isn't an official building. It's just a prototype, but then I will. That's part of it now as part of the development work, of course, to also make contact with the authorities so that they understand it and know how to deal with it. And then maybe you can also adapt to one thing or another. Basically, there is no reason now that speaks against it being approvable. The advantage is also that because it's underground, it means I can build on parts of a property that I'm not allowed to build on above ground.
I see.
In Austria, generally, unless the building regulations specify otherwise, you're only allowed to build on 25% of the property. So, for example, if 25% is already built on, am I still allowed to build something underground?
Yeah, I see. Okay, that's actually not bad. Yeah, okay.
That's interesting.
But also good. Good to know. Good to know. So if you ever want to build a habitat like that in your own garden, now you know how to go about it. Not bad, but I would always have one concern. I mean, on the moon, I don't think it's an issue, and on Mars, it's less of a problem too. Do you also have stories like that about mold or sealing, moisture? Is something like that included in the concept now too?
Yes, you need proper ventilation. And it's also like, let's say, if the building is made of wood or brick, those are materials that can buffer moisture, which I don't have with the foil. That's also the reason why the floor is flat, yeah. I have 20 centimeters of gravel, so it's mostly gravel, but there's a bit of lightweight aggregate mixed in as well, so I can lay the pipes freely in the floor. Then there's another layer of rigid foam boards on top for thermal insulation, and then comes the actual floor covering. The ventilation, the air flows in over this gravel bed, and then I also have a recirculation fan. That means the gravel together with the lightweight aggregate absorbs moisture and then releases it when possible, yeah.
That's brilliant, okay.
It also serves the purpose that during installation, the floor has to be pressed flat because otherwise it would always bulge up like a balloon. That, And in the gravel, I can also lay cables.
That's clever, very interesting. And I mean, on Earth, sure, that's just how you do it, how you build things. But for the Moon and Mars, are the pipes pre-installed in these panels, or do they have to be installed robotically or manually later?
Well, if there are any pipes for water or whatever, I mean, then they basically have to be installed inside. Or also, if something comes from the outside, you need a special passage, a dedicated passage valve that is airtight.
Mm-hmm.
It's also difficult in the Mars habitat or the Moon habitat to get the floor completely flat because the pressure there is much, much higher compared to the gravity. That means the floor is also curved there. And in the greenhouse, nothing happens. I feel sorry, the cat is being annoying. Stop it. There you go. He's scratching at the window.
Classic.
Yeah, I just feel this hollow that comes from the curve simply with soil in the greenhouse on the Moon or Mars. And with the living spaces, I also have to fill that in somehow, of course, and then I make a flat floor. Now listen, what are you doing there? Sorry, unbelievable.
It's true, we all live similar lives.
Yeah, right. That means the floor is filled, then laid. Yeah. Very good. And because I see it here again, doesn't that create this greenhouse effect? I mean, this glass house effect where it gets hot and stuffy when the sun is shining in all the time.
Yeah, that's why that's always the case. It's a bit easier for me than with the greenhouse because I don't need as much light, so that it's comfortable inside because there don't have to be plants growing in there, just people who need a pleasant atmosphere. I would say basically in mine, I have a fan, a gravel bed at the bottom, and that circulates the air. That means the gravel absorbs some of the heat peaks and then transfers them down into the ground. The walls also absorb some of it, of course, and if that's not enough, then the ventilation system kicks in because the air cools there now. The intake air is cooled down to, I don't know, let's say 14 degrees or so, and then comes in nice and cool. So even if it's 40 degrees outside, it cools the supply air down accordingly. And in addition, that's something I don't have in my prototype yet. I'll need more new funding for that. I want to develop a mobile shading system, something similar to the multi-layered films used to enclose satellites, that it works like an eyelid, since it's also curved, basically sliding over it, the mechanism. I need to do something quickly here. All right, it's working again.
Oh, I see.
So really speak like an eye. We're so
Exactly, it's like an eyelid. Is it possible that several mirrored films move up and down to insulate heat in winter? So in winter, it's simply closed at night and only opens during the day. And in summer, I close it, or let's say I close it halfway or 70% when the sun is really strong, just like a roller shutter, for example. And with that, I can control how much energy comes in. So I've already calculated all of that. Of course, calculations are theory, practice shows everything, but it should work in such a way that I almost, at least according to the calculations, it looks like with a normal single family house, you can achieve that you don't need to heat in the winter and that it's easy to keep cool in the summer. So that means the temperature inside shouldn't rise above 26 degrees. With the prototype, I have to heat a little bit in December and January.
Mm-hmm.
Very interesting. Cool.
I don't know. In total for the whole year, that's something like 5 kilowatt hours per square meter or so for the entire year. Okay?
Okay. That's not at all.
That's actually pretty manageable, isn't it? I can actually imagine it quite well. You said earlier that it's calculated, but theory is different. However, it actually is now. So if you say you've already got it down on paper, then it's basically an engineering problem now to implement it accordingly. Where do you see the biggest challenge at the moment, especially when it comes to this mobile shading? Because there would probably also be a bit of inspiration, or let's say inspiration in bionics, right? So could nature be a model for that?
Yes, nature is also a big role model for me. Of course, you shouldn't make the mistake of just copying things from nature, but you have to approach it with the same principle as nature. Nature, of course, works through trial and error, through mutations and so on. We can customize it slightly, but the principle remains the same. I always say that's my motto for design. You know, architecture is often also formalism. For me, I never want to create a form just for the sake of form. I say I do it just like nature does, or at least that's my goal. Nature is always unattainable, of course, but my goal is to design and develop my buildings or structures the way nature does.
Mm-hmm.
And that's also beautiful at the same time. So from my point of view, what is functional is also beautiful. So not functional in the sense of cheap or rational to produce, but rather with optimization of material usage. It's also natural that you feel comfortable in it, that everything fits. The forms of nature are ultimately optimized, and that's why we find them beautiful, I say now. A pure work of art that doesn't have to serve any function doesn't have to be beautiful either. It can also provoke or disturb you, which makes it a good work of art, unlike a utility or everyday object meant to function. Whether it's an airplane that has to be aerodynamic, a machine that has to work optimally, or some kind of static structure that provides support with minimal material and maximum strength. That's also automatically beautiful, just like I don't know, the body of a horse is beautiful because the muscles and the proportions of the legs are simply optimized. There are no extra masses.
Yeah, so nature is always a good role model for things like this.
Yeah.
With it.
Polarity shown here. So there are now 5 types of room modules. That's at the top left. So on the right side now in these white windows. The smallest one is a sphere with a diameter of 4 meters. Now it's actually 4 meters and 32 centimeters, which is flattened at the bottom. And then I can combine 2 such spheres, or 3 or 4 or 6 of these spheres together. And that creates room modules of different sizes. And then the surface is divided into a triangular grid. And within this triangular grid, I can also say a triangle might be transparent for a window, or I have some where I've left openings for passageways, and it's actually 2 layers of foil. We'll see that later in the photos. So there's an outer layer of foil that basically holds the structure together and is airtight, and then there's an inner layer of foil. That's a nylon fabric that's coated with polyurethane on one side, and the nylon side, the textile side is on the inside, and that always forms these triangular soft cushions, so everything inside is soft and textile. Then there are the walls.
It's very scalable, kind of classic, what I'd call a Lego principle.
Exactly. It's really about modularity. Each individual room module is itself modular because of these triangles, but the whole thing is also modular. And so on the left is an example. It's an X-ray axonometry showing how you can assemble an entire building from these modules.
Cool. Yeah, you can do all sorts of different things with it.
Does that also have a safety aspect or a safety related reason? Well, I think if such a module, for example, were hit by a meteorite and then, for example, started losing air, then the astronauts could also escape into a neighboring bubble. For example, would slamming the door work?
The modules are always connected by frame elements. On Earth, I don't need it, but on the Moon, airlock doors separate them. If a module is damaged, I just close the airlock door. It can fail for all I care. Afterward, I can calmly repair or replace it. Since it's so light and small, it might even be easier to just replace my entire module.
Just completely then. Yeah, I understand. Yeah.
Yeah, I can also imagine that you just have 5 spare modules stored in your own module. If something happens, just plug it in and inflate it. However, you'll still need to dig a lot again and remember the insulation layers. So here we have a few more additional examples.
Exactly, yes.
How you could interpret that. The ground temperatures.
That's another key detail. Because unlike on Mars, the air pressure here is only about 1 to 1.5% of the pressure or overpressure that I would have on Earth. And if the soil gets wet or anything like that, it could slide in. It wouldn't be able to hold the earth pressure permanently. Besides, for safety, in case the pressure is lost for any reason, I don't want everything to be buried. Now, the layer of soil that is directly adjacent is stabilized with just a little bit, only 3% by volume, of cement additive. And the orange part, you can see how it's stabilized there. Because we always fill in the soil layer by layer in the construction pit, and then it's always connected to the stabilized soil. I've already tested this, and it's also a method that's used in road construction when you want to stabilize the ground somewhere. And then I basically had a stable, almost like a negative mold of the inflatable.
Mm-hmm. Okay. Exciting. Now we get to this.
So now on the right, you can see a room module, and on the left, the airlock. The airlock will also remain visible like this. But what we see now with the room, except for the window, the rest will also be buried. And of course, in the spring, it will be covered with grass. Now, since I only finished in November, of course, nothing has grown on the hill yet.
Mm-hmm. Well, I can really imagine how beautiful it will look when everything is nice and green. It will definitely look romantic. These hoses sticking out of the ground are...
Those are the supply air hoses and exhaust air hoses. Back then, they weren't covered yet. Now they're more hidden. Back then, I had just finished the most important parts, so they were still sticking out of the ground like that.
Mm-hmm.
So, yeah, on the other hand, that's important. That's the window, which is made of 4 layers of transparent film. And there will also be this thermal insulation, which folds over like an eyelid added to it.
I still think it's crazy that it's simply made of film. It's something you just can't imagine, especially if you're not familiar with construction, architecture, and so on. I'm not a building physicist or engineer, but it's fascinating what film can do in that sense.
Yeah, that's a specialty even among civil engineers. A regular structural engineer who usually just works with concrete would also feel unsure about something like this.
Yeah, definitely. If I think way back, the structural engineering exams had nothing to do with things like this.
Wait, oh, the cat got on the keyboard. Oh, the window, it was the cat.
Maybe the cat wants to say something important.
You also want to say hello?
Yeah, hello, awesome.
Yeah, exciting.
Get off the keyboard.
There, we have another view.
Yes, there are more pictures now, letting you see it from different angles. That seems to be the entrance.
Now, for the prototype, it's basically a wooden frame that's covered with a sheet of plastic. But for the production version, I imagine it would be more like fiberglass or something like that. Like those portable toilets, really a finished box that can just be placed there. The other thing too.
Okay, yeah, I think you can make all of that very modular.
Always clarify which options are available for a prototype versus series production. Yes, I'm at the entrance, so in this case I also had those. I simply bought 2 side entrance doors made of wood at the hardware store and then sealed them with extra rubber gaskets. But it turns out that the wood moves. At first it's sealed, but then suddenly air whistles through again. Later I'll need proper ones like for boats or bulkhead doors. There are flood doors, of course they cost more, but if I think about the amount of work involved, maybe it's worth it. But if I have a whole single family house, then 4,000 or 5,000 euros for a door doesn't matter as much as it does for this small prototype.
So as a first prototype, it's not really a decisive factor, you know?
No, I'm just saying with prototypes, there are obviously a few teething problems, things that you learn about and only realize later.
Yeah, make it exist first, make it good later. So,
I mean, if you think about how many rockets Elon Musk has already blown up,
really,
my prototype works better than his first one.
yes, really, at least yours lets a bit of air through.
Yes.
That's totally fine. So, what do we have next? Right, you're sitting in there.
With the window above, and yes.
It's actually very spacious. You wouldn't think so, but it really does look very roomy.
Sure, the camera's wide-angle lens affects things a bit, but it's 15 square meters.
Yeah, does it?
Yeah, okay, so like a normal bedroom, yeah, but you can feel it, it's just more cozy. Because like I said, ceiling, wall, floor, it's kind of like a unit. And you can, for example, sit down on the floor and use the wall as a backrest right away. Because it's not down at the floor, it's not vertical, but it goes out. And it's actually a soft cushion.
Mm-hmm.
You can use it well.
Well, nice. That's really pleasant. And when you say it's similar to textile, it's not like a leather couch where you sit down and then you stick to it in the summer when you start to sweat.
No, the wall, you don't sit on the wall like you do on a couch, but it's basically like backpack fabric, like from a backpack or a sports jacket. That's what it's like. I could add an extra cotton layer or something, but cleaning and everything would be much more difficult. It's synthetic fiber fabric, but there's no plastic inside. It's just made that way.
So for the prototype, that would be classic over engineering, right? Probably.
Up on the ceiling, there's insulation on the inside right now. That'll change later. It's hemp insulation, and there's a plush fabric on top.
Right, you can easily recognize that. Yeah, exactly. The top few layers. Yes, exactly.
That's it, because it's very rounded and because it's textile and not plastered. The whole thing feels really cozy. It's like I always say, it feels like being in a womb, even though no one really knows what it looks like inside. And I wanted to find some photos of the inside of wombs for comparison. But they don't look like that because they don't form such a free volume. They always fold together inside, so it's folded up. But it's a nice analogy. I imagine in this case it was as yellow as the inside of an egg, like when a chick is being incubated.
That's a nice thought. That must be comfortable. And well, that's, yes, and there's a little kitchenette.
That was a bit later. I've already set it up a little. There are things that are gradually being added. There will be a shelf added on top and then on the other side as well. Right now, I just have a shelf with a coffee maker and a kettle. You can sit there comfortably and chill, have coffee, read, or browse the internet and things like that. I also have a converted barn outside that I use as a weekend house. But it's really cold there in the winter since I'm not there every day. And that's the converted barn. Well, it only gets up to 5 degrees inside. And when I start heating it up, it gets a few degrees warmer after 2 hours. But inside, I can get it up to 30 degrees if I want. So now I have to say one thing. There are still a few things that aren't optimal with the prototype. The window doesn't have the extra insulation yet. Then I was only able to completely close the construction pit in November. That means the soil was already cooled down at the bottom, and there are a few areas on the ceiling where the insulation doesn't overlap, where it's exposed. That means I'm definitely losing more heat now than I actually should later on. But still, last week overnight it was minus 13 degrees and I came in without any heating or anything. It was about 15 or 16 degrees inside then.
That's pretty impressive. Yeah, you can really see the inertia there, how much heat is actually stored there. And even if you wait a year now, I'd almost bet that by November 26th, it should still fit pretty well, even if the soil was exposed a bit longer.
Then on top of that, and if I also have the extra heat at the window, then it will definitely work much better. But in no time, with a tiny little 20 euro electric heater, I got it up to 29 degrees, and then I warmed myself up nicely after working outside.
You could turn it into a sauna.
Yeah, a sauna needs a bit more.
A little more, yeah.
But then you have the problem that maybe the textiles and whatever else is in there might suddenly start to give off gases.
Yeah.
Actually.
But Thomas, we've already talked about this before. But in the end, no matter what kind of habitat you build on the moon or Mars, in the end, you always want to line your living module with some kind of membrane anyway, right? To ensure a certain level of tightness, or are there other ways to ensure this tightness?
I've talked about this with all kinds of people, yeah, and none of them, well, with the current state of technology, You can't guarantee that any robot can do 3D printing in such a way that there aren't some fine hairline cracks or something like that in it. Besides, 3D printing requires a crazy amount of energy, but you basically have to, well, the regolith, which is basically silicon. You have to melt that, and of course with the nozzle, when you melt it, it's not that simple. A lot of energy is lost in the process, so it's not very efficient. Sintering is more cost-effective, since on the moon you can at least use concentrated sunlight. But with that, you can only produce rough bricks, and you can make a rough arch, but nothing that's airtight. That means you always need an inner membrane to line it. And so, well, I can say that's just a membrane system inside, and here I have a double one with the protective foam. But still, there might be people who will disagree with me now. But from my point of view, it's much easier and more reasonable to just make something inflatable. I think 3D printing is great for small things. If you say, I need a pipe sleeve or a door hinge or something like that, you can print all of that afterwards. Anything that's small and complicated, print it, great. But for large volumes where you really need heavy, large, thick wall surfaces, I don't see much sense in it.
Maybe at most, not to seal it, but simply to have a physical thick layer that protects against radiation and micrometeorites, and then protects the membrane in the end.
So let's put it this way. I could say I'll make sintered large bricks. They are then somehow built into a dome. And inside, I now have the inflatable structure. And in case the inflatable structure collapses, the dome would still remain on top. It's not buried, so you could repair it more easily. You'd have to weigh whether the time and other effort are worth it. So as I said, just 3D printing alone, and that's really the problem. None of these people who present their 3D printing Mars or Moon projects have ever stated how much energy they need. I have.
Yes.
I once estimated it myself, and I used the production of mineral wool as a benchmark. But I also had ChatGPT calculate and research it, and it just comes out to enormous amounts.
You always have this tension versus pressure issue as a problem too. So it's not 3D printing, but really tension versus pressure in terms of statics, because 3D printing creates a rigid wall or a rigid material, as you already said. And of course, these materials are great for bearing weight, specifically for compressive force in that sense. But it's extremely difficult for them to withstand tension. Now Sinwar ran off and he's back again.
Maybe I'll use some kind of fibers or something again, which can handle the tension. Just like with concrete.
Yeah, especially in the Moon or Mars area. In the end, inside we have air pressure. So if we assume we have half a bar or 1 bar inside and 0 outside, then theoretically the house wants to explode. So the walls are under tension in that sense, yeah.
Only tension.
Yeah.
And no matter what, even if it's made of aluminum, it's always a problem. You can't make straight walls because simply the...
No, yeah, right, exactly.
Consider it as an inflatable structure, yes. And the...
Yeah, classic single point of failure since we didn't calculate the tension, but okay.
For me, since I've been working with inflatable structures for so long, it's always present in the back of my mind. Tensile force. For regular architects, they always deal with gravity first and foremost. It's always just the grav.
Yeah, of course.
And you have to rethink that. Only then, or I also assume if, of course, we are on Earth, or I also assume if, of course, we are on Earth, we always have an up and down, but in a gravity-free spaceship, there isn't. You must rethink everything when planning. This also applies to orientation. How do I navigate a space with no up or down?
Yes, this project is a great example of the keep it simple principle. I don't know if that means anything to you or anyone out there.
I don't know, or...
So keep it simple in the end, right? So what's more likely that a highly complex 3D printing robot gets stuck in the fine Martian dust, or that it breaks down, or that something gets stuck while inflating? And that's exactly the problem you have. We have it. Actually, it's a simple product. Basically, it's clear. The implementation looks completely different, but compared to high-tech printing in terms of susceptibility to errors and so on, for a mission where there might not be any repair service at first, it just makes more sense. That's why I keep it simple. And that's why it's a great alternative.
The inflatable thing, I can produce it here on Earth at my leisure. I can inflate and test it 10 times. Of course, I can't do that with anything printed, especially if it's printed on Mars. I also think it's not just about how to build a Mars habitat as quickly, easily, and safely as possible. It's also about more than that. What impact does this have on other industries, including 3D printing?
Yes, that's right.
That's an important industrial factor, and that's why it's being promoted and sponsored.
Yes, that makes sense.
So we are now, I mean, we're not quite finished yet, but you're now in the prototype phase.
Yes.
How do you imagine that in the future? Will there be such pneumoplanet batteries that you can bundle by the dozens and somehow send them to Mars and the Moon? Will you be able to do that on Earth and buy it too? Can I say, hey, Thomas, I'm building a house. Can you design it for me? These are my basic requirements. Can I hire you for that? Let's say I need a house.
Yes, sure. Yes, that's the point. That's what it's supposed to be. It's adapted from space technology, but of course that's natural. Just like the Moon habitat and the Mars habitat look a bit different, this one also looks a bit different, of course. And it has different requirements for materials, etc. And that's just how it is now. At the beginning, I'll only be able to do a few pilot projects simply because the trust just isn't there yet. And it's also not developed for a mass market yet. So for now, I mainly see adventure tourism as the entry market. That you say, hey, we're building a small Mars village and people live there and they're brought there and live as if they're really taking part in a Mars mission. Of course, they're only allowed to go outside in a spacesuit, so basically like an analog mission, but for tourists. That's kind of what I have in mind right now.
I can even imagine that I would take this vacation as long as you don't have to put on a suit every single time you go outside. But if you just say you live in this habitat, you could spend a week in a small village in an earth house. Especially my wife has said several times that she loves these earth houses because the atmosphere there is apparently really, really pleasant. It's a different climate inside, yes.
Or you could make it a sci-fi garden house business. That would work too. I'm sure everything has a buyer.
Like an amusement park, kind of like you could do that. I would book this vacation. And I think it could also be very interesting for children that you just learn a little something along the way.
Definitely.
And have a little fun. And
my vision is, as you said, for children. Now they're building this Mars vacation village. Yes, and before it even opens for regular tourists, I would even mix it with regular analog missions where the Austrian Space Forum does this, so maybe they could help. That was originally my television casting show where kids and teens are chosen as the future ones who might actually travel to Mars as astronauts one day. And they are then selected and win a stay there where they receive 2 months of training, a kind of astronaut training. And all of that is simulated as realistically as possible, just like it would be on Mars.
Wasn't the Lunar Center built at the German Aerospace Center in Cologne? I'm not sure, but I think so. Was it built there later, etc.?
Yes, something lunar.
Yes, exactly. That would definitely be a use case, right? Like saying that in the next few years, something will be expanded in that direction, theoretically.
Yes. Well, I'm also in contact here with Gernot Gromer from the Austrian Space Forum. They keep doing Mars analog missions and would be interested, but they don't have the money and won't pay for it. So the difficulty is always finding someone who will actually finance it.
Yeah, that's usually the case.
They use regular tents or something, and then they build some kind of antechamber where they pretend it's an airlock. But of course, that's not the real thing. Sure, they just rent some cheap tent then and...
Yeah.
The thing is...
Yeah, they're also dependent on the sponsors who every year or every other year are kind enough to sponsor things.
Yeah.
But we need more sustainable models. That's why I think it's pretty cool to have this park, this adventure world there. That brings in money, and at the same time, it's being tried and tested basically under real conditions, so to speak. What happens when kids are running around and playing there, and how many scratches and cracks can the membrane really withstand? What if they're really...
Children fly to Mars so quickly?
Exactly. Children might be the analog to some injured astronauts who then hold on.
Do they then go insane after such a long journey, or what does that do to them psychologically?
Exactly. You can. Yeah, that's pretty cool. I just got an idea that we should talk about after the show.
Yeah, sure.
Very cool. So what else do we have there? We have once again
The ceiling with the plush. Now you can see this exactly plush ceiling with the internal hemp insulation. As I said, the internal hemp insulation isn't really optimal, and some condensation has formed now in winter. That's why it might not be quite as effective, the thermal insulation. But once the external insulation is added, the problem is solved. Plus, I have other advantages.
So here, this again.
Exactly. That's a small but important detail. There are always Velcro straps on the edges of these triangle pillows. And in these Velcro straps, I can discreetly run all the electrical cables. The question is always how to lay a cable, and this way is much faster. In a normal building, I always have to put an empty conduit into a drywall or brick wall and then pull the cable through. And with this, it's just open the Velcro, put the cable in, and you're done.
Clever.
And there is also, you can see it up there, so at the top of the picture where the cable ends up there, you'll notice every triangle has a small loop for hanging something. People often ask how to hang a picture there. This is how you do it. And the idea is also that I can use these loops or the Velcro straps to attach modular furniture there. We'll see in the later pictures how that can work. Yes, that's how it is now. This is basically already rendered for the serial product, so of course the airlock looks more elegant. Obviously,
Well, I could imagine living in that with my family. Honestly, that looks cool.
That's definitely something different. That looks really awesome again. That's cool.
That's really cool.
That's really sci-fi, at least visually. At least.
And just think about how much less building material you need, right?
yeah.
Yeah, definitely.
If you had the same living space with concrete and steel.
Yeah, well, I can say that very clearly. That's something we don't see in the pictures. Compared to a normal, conventionally built single-family house, yes, I save on primary energy. So for every 100 square meters of living space, I save 170,000 kilowatt hours of primary energy. With that, an electric car could drive 1 million kilometers. So, and if I build a wall out of reinforced concrete, for 1 cubic meter of reinforced concrete, I need 1,400 kilowatt hours of energy.
That's insane.
That's always, and of course we have that today. You can also build a practically passive house, zero energy house, or whatever using conventional methods, but the effort required is extremely high because they need a huge amount of thermal insulation. And I'll put it this way. If you start with, say, 10 centimeters of thermal insulation and you add another 10 centimeters, then the heat transfer is halved. But if I add another 10 centimeters, I only save another third, and so on. Yes, the more you add, the greater the effort becomes without much benefit.
I'm just imagining a little bit what life in there must be like and what's going on there. Maybe there are size restrictions or size limitations, what's possible on Earth and on other celestial bodies.
No, I mean, you have the modules. I mean, I could also develop other bigger modules as well. That's depending on the need.
Yes?
Currently, I still have some limitations. It's all relative. Well, you could also build 2 stories, but then how do I get the light down to both floors? So for now, it's basically always a single-story construction. But since I can green the roof surfaces again, you don't really lose much on the property except for the windows.
Maybe with those mirror tunnels, or I've seen that before, maybe that works.
I can lower the light, but maybe you also want to see outside. That's it.
Oh, I see. Okay.
You can definitely make a room module with a gallery where I still can, but then the earth mount just gets higher again. That's more difficult, since with a regular house and brick walls, I could make it 4 stories if building regulations permit. But then again, the built-up area is simply gone and not usable. And this way, it's part of the garden landscape.
Yeah, that's cool. the house is basically the garden at the same time.
I mean, in the renderings, it's always shown in a way that you actually see quite a lot of the roof surfaces. But in reality, because I just want to show the architecture, in reality, you can let everything grow over and cover it with soil, so only the windows would stand out. The question then is about solar panels. So what is always shown as black in these drawings? Those are solar films, but there are many possibilities, right? I intentionally said you could maybe leave one dome open because that's made of plastic and it's soft. That means I can sit and lie on it like on a lounge chair or garden furniture. You could even jump on it because it bounces and is soft.
Yeah, cool. So if you have a ceiling light or something like that hanging there and the kids are jumping around on the roof,
that doesn't really fit in there anyway. I would just use a few of those triangle cushion modules. They're made out of a translucent film and the lighting is integrated into them. In my case, I have it there now because the ceiling already juts in a little bit anyway. Due to the insulation, I only have an LED strip band around for direct lighting.
that's cool.
Yes, that would be a living room module with a conservatory integrated. So you can see, you can have regular windows where you can look outside and not feel like you're locked up in a basement.
I actually find it very pleasant that the windows are also a bit slanted diagonally at the top. I think the way the light comes in, it seems like everything is illuminated very naturally. It actually looks pretty cool.
A skylight is better for lighting, of course, but sometimes you just want visual contact with the outside.
Yeah, sure.
Yeah, and I love conservatories like that. That's always awesome.
If I ever have extra cash, I'll have something like that built in my garden instead of a regular shed. I'll ask you, Thomas, to build it for me.
Of course, like I said, building a single family house these days is extremely expensive, but that's just the way it is. I mean, by now, because of COVID and the war in Ukraine, construction costs have gone up a lot. So these days, expect to pay between 3,300 and 4,000 euros per square meter for a typical single-family house, including value-added tax. And mine can be done for about 2,100 to 2,400 euros. So it's already significantly cheaper, you could say. Yes, maybe there are some things where people just do certain jobs themselves and so on. That way you can also keep the costs down. That's the case with the earthworks. I mean, you obviously need an excavator, but you can also rent one and operate it yourself or do certain things like landscaping or interior work. You can install electrical wiring yourself. It doesn't always require an electrician, so you can save money.
Yeah, but that means you told me beforehand that you're still specifically looking for pilot projects for investors, right?
I was doing this construction work. I lost 6 kilos from August to October. Of course, I was often there myself and we did it. That was a learning phase. Now the prototype. I can't just tell any construction company what to do since there's no routine work here. Now I had an unskilled laborer and an architect colleague, my employee. Of course, we're not craftsmen either, and we just managed it that way. What did I want? Where was I? How did I get to this point now?
Because of investors and pilot projects.
So I say now is actually the time when I say now let's see how things go on. I have to, well, there's another grant that I'm trying to get. I have to see that I get investors. And now we'll see. On this 2 minutes, 2 million show, 3 of the investors have expressed interest in building such a prototype. So there's Mr. Falkensteiner from the hotel chain who is basically interested. We just have to sit down together this month and talk about it. But of course, nothing is fixed yet because statistically speaking, only 25% of all projects that get a positive response on the television show actually end up getting an investment or something like that. This is an opportunity for me, but I still need to look into other things.
I think there's something like that from the European Union. Let me think. I believe it's called the New European Bauhaus, actually. It's a topic in Brussels. It's basically about making this Green Deal attractive and livable. And theoretically, you could also get involved with this concept depending on which direction you want to take it, of course. But that just comes to mind spontaneously because it's also natural, of course. As I said, we just talked about construction costs, we talked about climate, or basically everything that's somehow related to construction. And that would definitely be included as well. Or the general topic of circular economy, those are all important points. This project definitely stands out.
Yes. Yes, it always is. I'll put it this way. When you have a new idea, I mean, it's not like everyone is just waiting and craving for someone to present a new idea. You really have to present it to people with some vehemence to spark their interest. But of course, there are a lot of people who have some kind of project and want funding or investment for it. There are people who need money and those who have money to invest. And of course, probably 90% of them aren't actually that interesting, to be honest. Now you have to get over that threshold. Someone has to take the time to look at it more closely and really be able to do so.
Yes.
Mm-hmm.
Understandable. Although here we really have a classic dual use case. So on the one hand, we have these classic high-tech applications. This is specifically about the space field, not dual use as seen in defense, but strictly within space. Also addressing issues here on Earth, such as housing shortages and energy crises.
Mm-hmm.
That's important too, because when people talk about space travel, it's sometimes criticized for wasting resources and energy. People ask why not use it to save the climate and so on. So it's important to show that it actually makes sense to do research in that direction.
Yeah. Unfortunately, this criticism always comes from the wrong side. And usually it's the side that, in a way, I don't know, has some kind of health problems anyway. But they're not even aware that the pacemaker is actually something that, for example, originated from the International Space Station or from some projects or other developments. And this would be a really great showcase project again. And above all, it's tangible. It's something you can see, something you can walk into. It's not just some microchip that will be built into cell phones for the next 7 generations. It's really something tangible, something you could already have on site, so to speak.
Almost everyone is connected to housing in some way. Well, yeah.
Yeah.
Exactly.
Fewer and fewer people can actually afford to live there.
Not crazy, because I mean, the only thing, without an inheritance, with any kind of normal job income, that's no longer possible nowadays. I mean, the only thing that might still work is that somewhere in the middle of nowhere where there's nothing, you might get, let's say, 100,000 euros for a rundown shack, a dilapidated one. And then you can somehow fix it up, but you won't have any public transportation or anything there. So it's crazy how this is developing, unfortunately.
That's true. Yeah, that's true. I could tell you all about it. I'm looking right now. We're currently searching, but well. So what else do we have there? Such a nice rendering.
Bedroom module now. On the wall is a modular shelving system. The advantage there is we have different room modules, but the curvature radius is always the same because it's always the same basic sphere module. And now the edges of the shelf would really fit together again with the Velcro straps. And then I can basically clamp the shelf in there. And then it hangs on the wall. And in the background, you can see a bit of sunlight reflecting in it. That's a fabric wardrobe. That's how it's intended. I still need a few wooden shelves, but they're mostly suspended with ropes clamped in place, attached to prefabricated rope holders. And instead of a plywood or veneer board around the outside as a front, it's the same fabric material as the wall again. That will then be sewn into the edges of the triangles, and I open it with zippers. Then I can add pockets on the outside, like on a backpack, where I can put socks, underwear, and things like that.
Super exciting. It already looks really cozy. I'd 3D print the armchair on site instead of bringing it along. What else?
Yes, the kitchen and the atrium are on the right.
Well, an atrium is also very, very cool. That's becoming popular now too. I've seen people building houses with them, like those Roman houses where you just have an atrium.
It's kind of become a trend somehow, right?
Yeah, definitely.
That's partly true, yeah.
Some houses now have no exterior windows or just a few, so all the light enters that way.
In densely built areas, there's nothing appealing outside anyway. In the past, I think in ancient Rome and also in the Orient, in old architecture, they always had courtyard houses where on the outside, it was relatively inconspicuous and closed, and life took place inside in the atrium, maybe with a small pool or water basin. And here we have this silly idea that everyone has their 500 square meter plot. Yeah, then around the house, there's just a 3 to 5 meter deep garden that you can't really use, and everyone can see what you're doing. You don't really have any privacy, but you present yourself to the outside world with your front yard and...
Yeah, well, that's how it is. I'm also a huge fan of this atrium concept. Also, the kind of microclimate it creates, it heats and cools at the same time. Really exciting. Oh, what do we have here?
Yeah, so as a basis, my sister has a house in Berchtesgaden. That's about 150 square meters. 3 years ago, they bought, well, again, the house. It was already a modern house, but they added insulation afterwards and then installed a photovoltaic system and also got an electric car. So, and on the left, this is their diagram now. And the green bars, basically, that's, let me make sure I'm not saying anything wrong. Also the purple bars that go down. That's the energy you have to buy every month. Then we have the green bars, the yellow bars. That's the energy gain each month from the photovoltaic system. The blue is what you can feed into the grid, and the green is the total consumption. Yes, so as we can see, that even in the summer, of course, they sometimes have to buy additional energy because the energy isn't always available when you need it. So at midday, there's a surplus. That's actually a problem now that the power grids don't want that electricity anymore in the summer at midday, but in winter, it's negative because photovoltaic systems produce very little then. So, and now I said, okay, let's take a look. If I have a pneumoplanet house where I don't need to heat or cool, what does the energy balance look like? Now you can see I've broken it down here. These light green lines, that is, in the bars, the light green part or this bright green part, that's what the electric car needs. That's of course constant throughout the whole year. At the top, what's now pale green, that's everything that was saved by the heating, and only the dark green part at the bottom remains. That's now the electricity consumption from the regular household appliances, which isn't affected by the system. So, of course, it's about the same every month. And that, of course, greatly reduces the electricity demand. So, the purple bars show the electricity that's still being used now, although if I were to subtract the electric car now, since that actually has nothing to do with the house, so there would only be a small amount left in December, January, and February when you'd need to buy electricity. We're already almost at that point. I say yes, I'm actually energy self-sufficient, and I had already planned for that in my concept anyway. You just add an emergency generator for 700 euros, which automatically turns on if there's not enough electricity otherwise. And then you could just cover those few kilowatt hours in winter with the emergency generator, and you wouldn't even need a grid connection, yeah.
Would it also be possible to solve the problem with large storage capacities?
I calculated it myself or had it calculated. So unfortunately, the storage units that are currently installed, for example, in a single family house as battery storage cost, let's say, 6,000 euros per battery, and that might last for a maximum of 2 days. It can only last overnight. That's all it's meant for. That means it would be an enormous effort. You'd have to make the photovoltaic system even bigger so that it still produces a bit more in winter, and you'd also have to make the battery bigger. The question is whether that's really worth it somewhere. I'm saying the effort to produce it compared to the energy I can gain from it just isn't worth it at some point. New technologies are coming with even better, more cost-effective, more efficient, etc., batteries. But at the moment, that's the situation that unfortunately, even without heating and cooling, you can't quite get there. But through technological advances in household appliances, maybe there will be washing machines that use only a third. I don't know. That's not really my field, of course.
Yes.
It's really a cost-benefit question now in a way. So what do we actually get as a return on investment? What do we really get out of it in the end?
I have to use 100 liters of gasoline in winter just to make electricity. Maybe that's no.
Yeah.
And maybe that's
No, that's true. Even for me as a layman, now I would say if I look at the right side here, it feels like I'm saving almost all of my electricity purchases in the winter. So that's one way to see it. For example, the house clearly costs more to plan or build than a prefab house. Yeah, it would really be interesting to see after how many years all this effort actually pays off. Because then, so to speak, you might not get a heating bill anymore or something like that.
like my sister did with a conventional house. Or what do you mean now? Which effort?
Well, exactly. So basically, just the effort to build it in general, that is, to design it in the first place, to get the whole thing up and running, just in general.
Hmm.
Yeah, that's totally hypothetical, of course, but yeah, sure.
Yeah, super exciting. I think exciting times are ahead of us.
Definitely.
Thomas, is there anything we haven't talked about yet that's really, really important?
Oof. Wait, let me think. I think.
Or do you have any other questions, Alessandro, that we haven't asked yet?
No, I think we've really talked about it in detail now, and we've really looked at everything. I thought it was really cool. Thomas as well, thank you for giving us such a great insight here. Really awesome. That's not something to be taken for granted. We both really appreciate it, and of course the community does too. And I also thought it was great that we talked a bit about energy, apart from all this space travel stuff, and partly about the cost factor and so on. That's really a great thing. No, I don't have any questions. Sinwa, do you? I'll turn it back to you.
So far, everything is clear. It's just important to me that we really give something to the audience as well. Cool things are waiting for us. The development speed is increasing and more things are happening that might not be so much in the public eye yet. But that's why we're going to steer the podcast more and more in that direction, so we can inform and educate about these smaller niche topics in space travel. That's why a big thank you to you, Thomas.
Mm-hmm.
Contact Thomas directly or just Google him. I'll also link him below in the video description so we can get in touch if anyone is interested. And Thomas, what's next for you and your project?
Now I have to look for funding for further development or find pilot projects. That's what's next for now. Yeah, I've uploaded the video now. I don't know, maybe you can, if you want, play something, maybe a few short parts from the video in motion. That would, of course, always be nicer. And yeah.
Yeah, let's take a look here.
What we'll definitely do is link the video below. So guys, please make sure to check the description. All the interesting and important points are included in this video as well. Yeah, exactly. That's the video, right? Yeah, exactly. That'll definitely be included below.
I wish I could have shown some of the construction process, including the excavation, for those interested in the technical and building details.
Exactly. So I'll, of course, link all of that, and feel free to subscribe to the channel. We'll definitely link that below as well. Alessandro recently started a YouTube channel too, so feel free to subscribe to Alessandro Rosner, both channels.
Just search for my real name and you'll find me.
Everything is, of course, linked below, my friends. And yeah.
Which I think is pretty cool as a final thought. Maybe also because I think, Thomas, you're showing us something with this whole project. Above all, that we're once again facing the extreme limits of space. I mean, typically we have no air, we have no heat, or we have very expensive transportation. We need this first to learn how to do things, for example. This is just one of many ways we can actually build sustainably on Earth as well. In the classic sense, necessity makes us a bit inventive. We need to learn how to survive on Mars to truly understand how to live on Earth. I think that's really cool. Just a brief anecdote to end.
That's really important. Research shouldn't just be focused on solving a specific problem. Sometimes it's important to just research things like what is, what if, simply because you want to know, or a little bit, can we do that? Can we travel to the moon? Can we even make it? And then suddenly so many other things come up. There are plenty of things people can work on. I'm not sure saying yes feels pointless since it won't feed any hungry children, right? We won't save the climate. Yeah, we won't save it with art and literature and sporting events either. But that's what human nature is all about. That we also deal with things that don't just serve the immediate satisfaction of needs, but we simply want to keep researching, experimenting.
Of course.
Interesting things just come out of it.
Absolutely. You don't need to justify yourself for that. Anything else is just classic whataboutism. And I always find it really unfortunate that, especially with such very niche topics, well, I'll say niche topics within the niche of space travel, you sometimes have to justify yourself. That's unhealthy. We need to stop it. Absolutely.
Yes, that's true. I completely agree with both of you. So,
all right.
Then I would like to sincerely thank both of you for your time. If you in the audience have questions, please write them in the comments. I believe Thomas and Alessandro will occasionally check the comments. Of course, I will too, and we will try to answer your questions if you have any. We're definitely looking forward to that. All right, my friends, that was the 7th episode of the Mars Chronicles podcast, the first one of the year 2026. After this break, we're going to end the pause and start bringing out content more regularly when it comes to the podcast. And Thomas, of course, we're always happy whenever you join us again, or if you have any updates, just let us know. And
there will always be something new. I'm convinced of that. Absolutely.
We're really looking forward to it. Good. Then I would like to once again thank the entire audience, both of you, and thank you for tuning in per aspera ad astra.
Thank you. I truly enjoyed it. Ciao, ciao. Ciao.